Hello students, welcome to maths class. So we will do some more problems from definite integrals. So from the definite integrals you are going to get two long questions. So today we will deal with long question. Okay. So what is that long question? Observe carefully. So evaluate 0 to 1 log of 1 plus x by 1 plus x square dx. Okay. So this is little bit different case. So for this problem first we have to go for substitution method. What is meant by substitution method? Instead of x we will take one value. Okay. So come on, you take put x is equal to tan theta in this problem. So we are converting the problem in terms of x to in terms of theta. So limits also we have to convert in terms of theta. So differentiating with respect to x on both sides, dx by d theta. So d by d theta of tan theta. D by d theta of tan theta is secant square theta. Okay. So what is your dx? Dx is equal to send d theta that side. So it is secant square theta d theta. Okay. So then now we converted the problem in terms of x to theta. So convert the limits also in terms of x to theta. So come on, upper limit. Okay. So what is your upper limit? X is equal to 1. So implies substitute this x is equal to 1 here. 1 is equal to tan theta. Okay. So 1 is equal to tan theta means tan of which angle is equals to 1? It is 45. Okay. So implies theta is equal to 45 is equal to pi by 4. Tan theta is equal to 1. Tan of which angle is equals to 1? That is 45. So theta is equal to 45 pi by 4. Next you go to the lower limit. Okay. So what is the lower limit given to you? It is 0. So x is equal to 0 implies 0 is equal to tan theta. Tan of which angle is 0? Tan 0 is 0. So theta is equal to 0. Okay. So therefore I given integral I is equal to integral 0 to 1 log of 1 plus x by 1 plus x square dx is equal to integral 0 to pi by 4 45, right, log of 1 plus tan theta. In x place we have taken tan theta by 1 plus tan square theta into dx. What is dx? Dx is secant square theta d theta. So it is secant square theta d theta. Okay. So 1 plus tan square theta is secant square theta. So is equal to integral 0 to pi by 4 log of 1 plus tan theta by secant square theta into secant square theta d theta. Secant square theta cancel. This is your I. Okay. So and you know it very well, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. Whenever 0 to some limit is there, we have to take in its place 0 to a f of a minus x dx, right. So therefore I is equal to integral 0 to pi by 4. What is that? Log of 1 plus tan theta d theta is equal to, instead of theta, right, instead of theta here, instead of x we have taken a minus x. So here instead of theta we have to take pi minus 4 minus theta, right. So is equal to 0 to pi by 4 log of 1 plus tan of a minus x form. In a place we are having pi by 4. So pi by 4 minus x into what is that? D theta, right? So here x is not there, theta is there. So pi by 4 minus theta. In general a minus x, but here instead in place of x we are having theta. In place of x we are having theta. So it is pi minus 4 minus theta. Okay, so is equal to integral 0 to pi by 4 log of 1 plus tan of a minus b, right? So tan of a minus b is equal to, formula is tan a minus tan b by 1 plus tan a into tan b. Okay, so that formula we have to apply here. In a place you are having pi by 4 and in b place you are having theta. So come on, we can write that as tan of pi by 4 minus tan of theta by 1 plus tan of pi by 4 into tan theta, okay, into d theta. Okay, so tan pi by 4 is a tan 45. Tan 45 is 1, right? So is equal to integral 0 to pi by 4 log of 1 plus 1 minus tan theta by 1 plus tan theta into d theta. Now take the LCM, this 1 plus tan theta. So I is equal to 0 to pi by 4 log of, come on, what is that? It is 1 plus tan theta. So it is 1 plus tan theta plus 1 minus tan theta d theta. So minus tan theta plus tan theta cancel. So I is equal to integral 0 to pi by 4 log of 1 plus 1. What is that? It is 2 by 1 plus tan theta d theta. Now it is of the form log of a by b, right? Log of a by b is log a minus log b form. So here your I is equal to integral 0 to pi by 4. In a place we are having 2, in b place we are having 1 plus tan theta. So it is log 2 minus log of 1 plus tan theta, okay, into d theta. So inside the integral, whenever plus or minus sign are there, we have to take separate integrals, right? So I is equal to integral 0 to pi by 4 log 2 into d theta minus integral 0 to pi by 4 log of 1 plus tan theta d theta. Okay, so log 2, it is a number, 2 is a number, log 2 means it is a constant, right, outside. So I is equal to, right, log 2 outside 0 to pi by 4 d theta minus, what is this? This is I. Integral 0 to pi by 4 log of 1 plus tan theta d theta is I. So come on, I plus I, it is 2I is equal to log 2 into integral d theta is theta, right? It is 0 to pi by 4. Okay, so once the integration completed, we have to take the limits on right side. After that, in that theta place first upper limit minus lower limit. So is equal to, it is log 2 into upper limit pi by 4 minus lower limit 0. So we can write first pi by 4 into log 2. Pi by 4 minus 0 means pi by 4 only, isn't it? So log 2 into pi by 4. So it is pi by 4 log 2. I is equal to send to this side, that is pi by 8 log 2 is the answer of your question. Okay, so once again see how we can split this problem means, see first we have to convert this problem in terms of theta, that means we are going to substitution method. Okay, so come on, evaluate integral 0 to 1 log of 1 plus x by 1 plus x square dx. There is no direct formula in integrals log of 1 plus x by 1 plus x square dx. For that sake, first we have taken the substitution method so that it will come into one standard form of the integral formula. So for that you take x is equal to tan theta. Differentiate x with respect to theta on both sides. So dx by d theta is equal to d by d theta of tan theta. So what is the derivative of tan theta? It is secant square theta. So come on, dx is equal to send d theta, that side dx is equal to secant square theta d theta. That means we are converting the problem in terms of theta. X2 we are, x terms are there, given problem is in terms of x and we are converting them in terms of theta. So limits also in the given problem, limits will be in terms of x, from x is equal to 0 to x is equal to 1, lower limit and upper limit, isn't it? So we have to change the limits also. So upper limit, what is the upper limit? X is equal to 1 in the given question. So substitute that x is equal to 1 in this value. 1 is equal to tan theta. Theta means angle. Tan of which angle is equals to 1 means it is 45. So theta is equal to 45. If we want to write in terms of pi, it is 180 by 4, that is pi by 4. Next come to the lower limit. Lower limit is x is equal to 0, right? 0 is equal to tan theta. Tan of which angle is equals to 0? It is tan 0 is 0, right? So that's why your theta is 0. So we converted the problem in terms of thetas now. So therefore you take your integral I is equal to integral 0 to 1 log of 1 plus x by 1 plus x square dx. Wherever x is there you substitute tan theta, and in dx place we got dx is equal to secant square theta d theta, substitute secant square theta d theta. So 1 plus tan square is secant square theta. So secant square theta cancel, right? So therefore integral 0 to a f of x dx. Observe, this is 0 and this is pi by 4. Whenever in definite integrals any question is in the form of integral 0 to a f of x dx, in x place we will take a minus x. But here our problem is not in terms of x, it is in terms of theta. So in theta place we have to take a minus theta form, where in a place we are having pi by 4. That's why I have taken this I is equal to. After that we applied this formula 0 to pi by 4 log of 1 plus, instead of theta we have to take a minus theta form. So that is pi by 4 minus theta into d theta. Okay, so after that it is tan of a minus b formula. Tan of a minus b formula is tan a minus tan b by 1 plus tan a into tan b. You consider this as a, this as b. So tan a minus tan b by 1 plus tan a into tan b. So tan a is 1 minus tan theta by 1 plus 1 into tan theta, that is tan theta. After that take the LCM, right? 1 plus tan theta is the LCM. So 1 into 1 plus tan theta plus 1 minus tan theta plus tan theta minus tan theta cancel. So it is tan of 1 plus 1 2 by 1 plus tan theta. So it is of the form log m by n, log m by n is log m minus log n. Log m by n is equal to log m minus log n. There is a formula in logarithms. So you consider this as m, this as n. So log m minus log n. Inside the integral, if a minus or plus sign is there, we have to take a separate integrals. Okay, so you take the separate integrals, and 2 is a number. Log 2 means it is a constant. Write that constant outside. Right, so log 2 into integral 0 to pi by 4 d theta. Right, so d theta, integral d theta is theta, and bring that this is nothing but our I, isn't it? If you observe here, after cancellation secant square theta, our I is equal to integral 0 to pi by 4 log of 1 plus tan theta, that is I. Okay, so you bring that I this side, minus I plus I, 2I. 2I is equal to, and integral d theta value is theta. Okay, so after the integration you have to take the values on right side. After that, first in a theta place we have to substitute the upper limit, then we have to substitute the lower limit. In the middle, minus sign will be there. So it is pi by 4 minus 0, that is pi by 4. So generally it is a constant. We will write this side. So pi by 4 into log 2. This is your 2I. Right, we want only I. We have taken the given question as I. So I means sending that to that side. Here it is multiplying. If you send that side, it will divide. Here 4 is there. 4 2s are 8. That's why you got pi by 8 into log 2 is the answer of this question. Okay, so in this problem, first we have to see whether the integral is in direct formula form or not. If it is not in a direct formula form, right, so we have to go for substitution, and we have to reduce the integral into standard form. So for that sake, I have taken x is equal to tan theta. Differentiating, we will get that as a secant square theta. So that downwards 1 plus tan square, secant square will get cancel, and we will get this one. So after this, if we observe our definite integral form, it is of the form integral 0 to a. See, 0 is there and pi by 4 is there. In a place it is pi by 4, 0 to a, f of x dx is nothing but integral 0 to a, f of a minus x dx. But in place of x, here we are having theta. So in place of theta, we have to take pi by 4 minus theta. Okay, so and what is this 0 to a, right? In a place we are having pi by 4 value. Okay, so integral 0 to pi by 4 log of 1 plus tan theta d theta is integral 0 to pi by 4 log of 1 plus same a minus x form. So in x place theta, a place pi by 4. So pi by 4 minus theta. Again we got in which form? Tan a minus tan b form. Formula, trigonometric formula, right? So it is a formula, right? So tan of a minus b is equal to tan a minus tan b by 1 plus tan a tan b. So you consider pi by 4 as a and theta as b. Substitute tan a minus tan b by 1 plus tan a into tan b, and tan a is tan pi by 4. Pi by 4 means 45, right? So tan 45 value is equals to 1 minus tan theta by 1 plus tan theta, and this is the LCM we can take. Here downwards it is not there, so we have to multiply 1 with 1 plus tan theta. So 1 plus tan theta plus 1 minus tan theta plus minus cancel. So 2 by 1 plus tan theta. Now it is of the form log of m by n, right? Log of m by n, log m minus log n. Okay, so you consider log 2 minus log. Whenever plus minus, we have to take the separate integrals, then apply the upper limit minus lower limit in it. You will get your answer. Okay, so be careful. We used how many formulas here? So we have taken 1 plus tan square theta as a secant square theta, one trigonometric formula, and tan of a minus b is equal to tan a minus tan b by 1 plus tan a into tan b, again trigonometric formula. And one logarithm formula we used, log of m by n is log m minus log n. Okay, and another definite integral formula, whenever the limits are 0 to a f of x dx, it is 0 to a f of a minus x dx, right. So that formula we used. Okay, at the end, after the completion of integral, we have to write the limits on the right side, then first upper limit minus lower limit, substitute and simplify, you will get your required integral value. I have taken the question as I, so at the end I got I is equal to pi by 8 log 2. That means the integral value is pi by 8 log 2. Okay, so practice this problem perfectly. That's all for today. Have a nice day.